Hi, today I'm gonna present this paper, a microfluidic platform for in situ investigation of biofilm formation and its treatment under controlled conditions. Adhesion and early biofilm development for understanding the physiology of sessile bacteria and the development of antimicrobial biomaterials. We know that biofilm represents a huge risk in the antibiotic resistance. For this, they decide to study the use of microfluidic device growth because it makes easy to study bacterial adhesion and biofilm formation. This system allows real-time monitoring and helps to study the killing activity of the antibiotic treatment and the single cells. In the results and discussion, they tested a microfluidic chip made out of PDMS bonded on glass. And then they observed after 3 hours of continued inoculation using Escherichia coli as the model bacteria strain. They used this model for observe how is the killing activity of an antibiotic in a real time. Here we can observe they used two kind of mediums, M9 medium and TSB medium. Here we have the schematic, the design of the microfluidic device, and it has 3 inlets, one for medium channel 1. In the middle, they have the bacteria injection channel, and the third, it was the medium channel 2, and it has the waves. So first they study how it is the adhesion of the bacteria. So they inoculation of bacteria through the central channel. Then they study how it is the proliferation. So they stop the bacterial injection and then they have a constant flow of the medium. And then they observe how the bacteria are growing according medium M9 or TSB. And finally, they study how it is the antibiotic treatment. So they injection for one inlet, the antibiotic colistin and propidium iodide. That is an indicator of cell death. So after they do that, they study how is the surface coverage depending by the medium they use. So here we can observe in this graphic that the addition of bacteria in TSB was linear with a constant addition rate. In the other side, with the M9 medium, the growing was faster, but we can observe that it quickly decreased. And the rate of growth was faster for the first 2.5 hours in both cases. Here we can observe that the importance of the medium selection for the growing of bacteria. Okay, here we can observe how the view of this device. So when they use the TSB medium, the biofilm format is more thick, and with M9 medium is more thin the biofilm format. So it is reflect that the biofilm was better in TSB medium because it has a better coverage and it is increased by the pass of the time. Here they study how it was the bacterial proliferation. So we can observe that in the first hours, the proliferation of the bacteria was better in the M9 medium than in TSB medium. But after the 10 hours, the proliferation of the bacteria was better in TSB mediums. Here in this graphic, we can observe the same. So after the 10 hours, the proliferation of bacteria in TSB growing increase. And in the another medium, M9, it is growing constantly. It maintains constantly. Okay, they study how it was the antibiotic activity. So the platform was used to direct visualization of single lighted cells and reveals the performance of the antibiotic. So in this case, they inject the colistin and they observe how it is the effect in the pass of the time. So at the 0 minutes, we can observe that it doesn't happen. It nothing happen. And then when the pass of the time in the 80 minutes, we can observe the killing effect of colistin can be recorded down to the single cell level. In conclusion, we can say, in conclusion, they say the nutrients are so important and are reflected by the growing of the bacteria, the adhesion, the proliferation, and the biofilm. And it is very useful, this kind of microfluidic device, because the platform enables the study of a wide range of organisms and growth conditions.